Happy Monday.
Happy Monday. How's it going, Joe?
Good, good. How was your weekend?
That was good. It was restful, and it's funny. Weekends these days are a time to get caught up on work, so the rest of the week is better. So,
Know what you're saying. Yeah,
yeah, yeah,
yeah. But yeah, I don't know an easy way out of that either. So my Sundays are usually spent the afternoons just basically piling through the work I need to get done on Monday. So
yeah, yeah. So the rest of the week is less chaotic. So,
mhm.
yeah,
Yeah.
hopefully post COVID we'll all be able to reclaim more of a work life balance. But it seems like a thing that just doesn't completely exist right now.
Well,
So
as an old boss of mine told me once, his idea of a holiday is working a 60-hour a week. So
we can all work toward that, I
something to
guess.
aspire to for sure.
Yeah,
Yeah.
yeah.
Cool. I think this week we wanted to cover a couple of articles that we'd seen on social media and various Slack channels we're in. And so the two articles are how to become a data engineer, and then the other one is we don't need data scientists, we need data engineers. So um, and it sort of fits with a theme that we've been hearing a lot in various office hours and data chats that we participate in. There's a lot of questions about how do I become a data engineer, um, you know, and also what's like if I'm a data scientist, how do I become a data engineer? What's the market like now for data scientists and data engineers? I think these two articles which recently came out, I think at least cover some of those questions, and then of course we're going to have our opinions on these articles. So you want to kick it off with how to become a data engineer that in your
Yeah, and
thoughts on
I'll
that
just
article?
say, like, we both read these articles, and on the one hand, it was kind of like preaching to the choir, right? There are a lot of themes in both of these articles that we completely agree with. Then we kind of also felt compelled to add a few things that we felt were missing from both of these articles, in spite of the really good perspectives here. And so that's part of what this discussion is about, I think. But yeah,
Mm-hmm.
how to become a data engineer? Like, what is the core skill set? What's the difference between that and becoming a data scientist? And how does it differ from being a software developer?
Let's go through what this article talks about. So, I mean, and it talks, at the top, it has the data science hierarchy of needs. If you want to scroll some more in that
Yeah,
article,
yeah. We can go down here a bit.
and it kind of goes through maybe some, skill sets in terms of, knowledge of language, knowledge of platforms, um, you know,
Databases,
mhm.
SQL, like just very core skills that are kind of a baseline, right? Table stakes, as you would say.
Yeah, I want to keep scrolling on that too.
Yeah, yeah.
Yes, let's get to the skill set here. So, I mean, the author of this post talks about algorithms and data structures as being, you know, an important part of a data engineer's skill set. Um, one of the things I think that stood out to you was, the sentence above where it talks about SQL databases. You want to talk more about that?
Yeah, yeah. So I found this a bit interesting, and this resonates with some things that we've seen at various startups, which is the author talks about SQL databases as things like SQLite, PostgreSQL, MySQL, which those are all very important SQL databases. They're very performant, quality databases in their respective realms. But I think there was not a lot of differentiation here between OLTP and OLAP. So online transaction processing and online analytics processing databases. And day to day, most of what we work with is OLAP, online analytics processing databases. Now, you still have to interact with row-based databases, but it's mostly like to suck data out and then get it into your analytics system. And once it's in there, then you can do the interesting stuff with it. And that's where the data engineer's job really starts to get interesting. So yeah, I think these skill sets are important, but I think you need to add to that understanding columnar databases, really understanding things like Redshift, BigQuery, Snowflake, Presto, possibly Hive, depending on what stack you're working on. Definitely Spark.
Hmm.
Yeah.
Yeah, I think it's there's no shortage of technologies or paradigms
Right.
to understand. I think that this article, with respect to algorithms and data structures, for example, it's a good starting point.
Right.
I think we're of kind of differing opinions on the algorithms piece. I think I'm more of the opinion that having a knowledge of algorithms um, definitely helps, and understanding how B trees work and relational databases is, I think, to me, that's kind of mandatory. I think you have a different opinion on that. And the reason I think that I'm a bit more hardcore on this is that if you should know how your source systems work. And so it's basically just, to me, it's having the skill set to even call yourself an engineer versus some other noun.
Yeah. I
Right.
think
So
part of what we discussed before the actual recorded discussion was the ongoing debate about whiteboard interviews, knowledge of the algorithms curriculum. I think there's a lot of soul searching going on in the tech industry about what people should come into the job with, and fundamentally how to evaluate candidates. And so that's part of the issue that got raised here. I think the other thing we both probably agreed on is that this is a good starting point, but there are a lot of algorithmic type bits of knowledge that are not covered here. So for example, what is a columnar database? How does it work? How does it differ from, say, a MySQL or Postgres row-based database? How does it handle commits? How does it handle history? Like all these kinds of things that data engineers really need to understand extremely well as they get further into handling of analytics data and big data scale systems.
Yeah, you want to keep scrolling on this article. So, I mean, the
Some,
author also points out SQL.
yep, and
We
we
both agree it's important.
Yep. It's just not to beat a dead horse, but like we talk about SQL all the time, and we will continue to talk about SQL all the time. And we teach classes on SQL as well. We're teaching another one starting in a couple of months, in fact, because we think it's so valuable across the board for data engineers, for analysts, and for data scientists as well. It's maybe a gap that we see in a lot of people's skill sets where they're good data scientists. They could be better data scientists actually if they understood SQL, because there's a lot of stuff that is very slow for them right now that could be really easy if they knew SQL better.
Mm-hmm.
Yeah.
Yeah, I mean, I think SQL is probably going to outlive all of us.
Yeah.
We'll see, but
here's one thing.
It's probably going to outlive your career.
Oh, I completely agree. It's like geological time scale. That's SQL, right? Like it's going to be with us for eternity. Probably it's much more of like a C or C++ versus a COBOL. Granted, COBOL is still around too, but it's not. It's shrinking, right? COBOL is shrinking over time. C and C++ remain really important at this point, and so will SQL.
So I mean, this ties into the section below too, where he's talking about. You want to scroll a bit? Programming, right? So Python, Java, Scala. I mean, and so this is where I sort of started. I think this article was maybe a good baseline. It's definitely incomplete.
I think
so. From a language perspective, I can't disagree that knowing Python, Java, and Scala are important. I mean, I would if I were to pick any of the three, I would definitely go with Python at this point, just because it's a lot of the more modern tooling is, kind of Python first.
Right.
And so, but that said, a lot of the open source, big data tools are JVM based. You're going to need to know Java or Scala if you want to be effective in those.
And programming paradigms, right? So do you understand object-oriented structures? Do you understand how libraries are organized inside of a framework? That's really important. Often if you're a data engineer, you're going to be responsible for managing some internal code base that maybe it could be like Airflow plugins, it could be Spark plugins, and then interacting with the data scientists about those things. And so how do you manage your code? How do you organize? How do you make it maintainable? Those are really critical skills, I think.
And the other part of that is, I think, with Python especially, there's a lot of attention on using pandas for stuff where you could use SQL.
Exactly.
It drives me kind of batty, and so I think the advice for that is for data engineers and data scientists. If you don't know SQL, it's going to make you.
And that's where I was going to, like, one thing that I slightly disagreed with, well, maybe strongly disagreed with actually, is it says intermediate SQL. So first of all, I wanted to drill down on that a bit more. Generally, data engineers don't need to know that much about transactions, right? They don't need to know that much about writing Postgres transactions and all the different parameters. They should know what a transaction is, definitely, and how they work, but they're not going to be like developing the application backend. But in terms of analytics, I expect them to be very advanced. And so, for example, we frequently see use cases where people are like, I need Spark so I can parse raw data. And I'm like, well, that's something you can do pretty well with SQL, and it's probably going to be way less management overhead to be parsing data using SQL rather than getting into Spark to do that. When you get into things like stemming and tokenization of words, then you probably want to look more.
Yeah, but isn't that something like an analyst or a data scientist is typically going to do? Like, when is a data engineer going to have to parse stuff like that?
I'm thinking more in terms of like data pipelines. So a typical example would be they get some really gnarly raw data out of an API that's not formatted very well. They need to extract some things from it. And often that's something where you can do an ingest step. Once you get it into your database, you can do some parsing of that data to pull out the things that you actually care about. But also for analysts and data scientists, absolutely.
Yeah.
Yeah.
And so, yeah, you could go down in this article too, because it talks about data tools and they're kind of hodgepodge between, the programming languages and the big data tools. But I think we can both agree that something like Hadoop, I don't know that you need to know Hadoop these days. I could make an argument that you probably don't need to know Spark.
And that's going to be more controversial with a lot
It's
of people.
controversial, but I would say Spark's place in the universe, I don't know if it's as relevant as it used to be.
Yeah, it's widely used. I don't know if I'd call it like a hot up and coming technology
It's
anymore.
mature, and if
It's
you
not
have a
like it.
company that uses Spark, I mean, by all
Yeah,
means, learn it. But I don't think it's necessary, to jump right into Spark. I would say maybe in
right.
2015, 2014, that was the cool thing. But the world's sort of, it seems like the world's definitely consolidating more towards, kind of data warehouses, right? Back to the future, Snowflake, BigQuery, Synapse, Redshift, and so forth. I know that you know uh, Databricks is pushing out Lakehouse now, as well as Delta Lake, and Hive Acid's sort of doing the same thing. But
Right.
it's, and more power to them. I mean, they need to work to keep their platforms current and so forth. So I mean, hopefully they're all successful at it. But in this day and age, like Hadoop, I don't know, unless you joined a company that's using Hadoop, I don't know that it's a skill set that you actively need to invest your time into.
It's funny. It's really bizarre to say this, but at this point, Hadoop is kind of like COBOL in some sense, but on a much faster timeline, more compressed timeline. Like Hadoop is now in a lot of companies, but it's not the new thing anymore. It's something you have to maintain, and eventually it will probably get ripped out when companies go to the cloud and go into like a Snowflake or a BigQuery.
Mm-hmm.
Yeah,
Yeah, and then the other thing that this doesn't touch on is all the pipelining tools as well. And in
yeah,
modern, if we're going to talk open source, um, warehousing like ClickHouse or the app Druid here, which is cool. We're big fans of
yeah,
Druid. Shout out to our friends at Imply,
yeah.
and so forth. So yeah, it's so I think this article was like, it was a good step in the right direction. Obviously, there's a lot to if you're to make a comprehensive article, that would be a book actually. And so props to the author of this article for at least taking a stab at stuff. I think it was pretty incomplete, but and I would say that if you use this to as your rubric to become a data engineer, I would definitely seek out other articles
Right.
to complement this one. I wouldn't take the advice of this solely as like your marching orders to become a data engineer.
Yeah. And so, among other things, I'd want to see a much deeper discussion of what object storage is, right? So, it turns out object storage now across the board is very, very important in the cloud data engineering space. And that's where data engineering is going. That's basically the replacement for Hadoop. And you need to understand how that works, like what the underlying model is.
Mm-hmm.
Things like what's a columnar database? How does it organize data? How do you use it efficiently? What does the
Yep.
commit model look like for these modern data warehouses? How do they like handle updates? That's a really important
Yeah.
question because actually, I think we both agree we've seen numerous cases where not understanding the commit model has just caused these systems to almost grind to a halt because they're abused by people who don't quite get how they work.
that's just for the analytics side. I mean,
Yeah, yeah,
we've
that's
taken
right.
data engineering certifications. I mean, I hold
Yeah,
certs in AWS and GCP and soon to be Azure. And it's like, in these exams, though, it's interesting because they don't just focus on the analytics piece. Like AWS, a large majority of the exam is actually focused on Dynamo.
yeah,
Azure, large majority of the exam is Cosmos DB. So, I can make a very strong argument. Sorry, and then GCP, Spanner and Bigtable are also
yeah.
in data store. They're all
And
talked
cloud,
about,
yeah,
and you better damn well know these things. So, I guess the point is, in order to, I would say, become a data engineer, you should understand, not just analytical databases, but just the universe of databases in general. Again, you're dealing
Mhm.
with data and you're engineering it, right? And so you need to understand kind of the continuum of your source systems and so forth. So that's, I think, where I would probably add to this article is that it just, NoSQL didn't get a lot of attention, but that's, what a lot of, at least with the cloud providers, that's what they're all pushing right now is
Yeah,
NoSQL, or in GCP's case, to other technologies like Spanner, which are SQL based, but you need to know how Spanner works in order to use it.
exactly. You're going to be much, much better off if you
Mm-hmm.
do. It's that curse of familiarity, right? Someone hands you a technology and it's like, oh, this looks just like MySQL. I'll treat it like MySQL. And it's like, well, it will
Yeah.
be better if you do these other things instead.
Yeah. And also understanding, again, you mentioned object store, and it's like, how does, uh, what's the best way to set up object store so it's performant? There are
Exactly.
tricks.
Yeah, absolutely.
And how, and what are the ways you can get screwed over with object store? There are definitely ways.
Oh yeah, there
So,
are ways to lose a lot of
um,
data if you're not careful. It's
mhm,
really critical that you understand some of those details. I mean,
yeah.
same things you show up in a lot of distributed systems, right? How can applications step on each other to mess up stored objects? That's a
Hmm.
very important
So I'm
question.
glad this author also pointed out, distributed systems, if you want to scroll down in this article here.
Yeah,
And the data pipelines, again, it's a list. I can't say it's complete, but it's a list. Uh,
yeah, it's a
you
good
know,
start. It was good for us to riff on this, and we agree with a lot of it. But things like airflow, it mentions, that's great. I think at this point, Luigi is becoming a bit more legacy. Um,
you start to
prefects
see
seem to be
Dagster, I
up and
think,
coming.
more in Prefect.
Yeah, yeah. See, prefect I definitely view as up and coming, and then NiFi is actually a very different paradigm from some of these other options. And so it's important to understand the differences in how they orchestrate and how they handle data too.
Hmm.
Yeah.
So,
And maybe
uh,
that's that's one of our themes is maybe we'll put this in the show notes, but like there are a lot of papers and books you can read that kind of give you a bigger context of what's going on in the data engineering space and the different types of ETL and ELT and how they've fragmented and what paradigms are really popular.
mhm. Yeah. And still, I would say the best book on it, the author points out, designing data intensive applications. I mean, I
Mhm.
always plug this book. The sad thing is it's also almost 4 years old.
Yeah,
And, if you're an author out there, or, want to write about, modern data engineering, I think there's a big, big space for that. So it's something we probably should
yeah. I mean,
as
the
well.
truth is too, there's a big space for people to talk specifically about cloud data engineering because even say in 2016, the focus was still on infrastructure like Hadoop, stand up these nodes and such. But a lot of those practices are kind of they're not things you necessarily need to worry about as much if you're using a managed system, but there are other aspects to the managed system that you need to understand so that
Mhm.
you use it appropriately, even if it's fully managed.
Hop to the next article.
Yeah. And this is a theme we keep seeing all over the place, and we've been saying the same thing for a while. So it's nice we're kind of drinking our own Kool-Aid on this article.
Yeah, yeah. I mean, this article is a bit interesting. If you want to scroll down, I mean,
Yeah.
so it talks about basically, the author had gone through and done an analysis on data roles, and specifically, as you can point out here, analysis of data roles being hired at every company coming out of Y Combinator since 2012.
Yeah. And that
Um,
it's a very
so
relevant sample. It's a limited sample, but it's like a very relevant sample
I
for
think
where
it's a relevant sample if you're a startup,
yeah.
right? And so if you keep going down in the article, it's interesting because it talks about how
Good enough.
uh,
Yeah.
If you, actually, there's a couple of charts. If you go down
Yeah,
further.
yeah. Let's look at the charts. We can go way
So
down.
yeah, so roles, right? So the thesis of this article is there's more data engineering roles than there are data science roles.
Yeah.
Um, Again, I think it'd be nice to zoom out and understand that maybe the broader context, with non-YC companies, and understand if the same trend holds or not. But just going off of the article's thesis, given the methodology of this study, it's something that we see
Yeah.
quite often.
Well, and I mean, I don't know. What do you think? But my general anecdotal experience is that for more established online retailers as opposed to startups, this becomes even more important. They just need data delivered in a very consistent way. And yes, they care about recommenders and all kinds of data science, but they care about those pipelines running consistently, presenting consistent views of data, and making consistent business decisions.
Yeah, I mean, I would say e-com and lots of other businesses too, right?
Yeah.
Fintech, we got lots of customers in that area too, and it's the same thing. If you don't have data, it's kind of hard to make a recommendation, right?
Yeah. And consistent
Or
data.
it's hard to make a credit score or any of that stuff. So,
Exactly.
and traditionally these roles were maybe done by or these jobs were done by software engineers. And we'll talk more about sort of that fine line in a bit. If you can scroll down in the article a bit more, there's
Yeah.
a few other points here.
This was a percentage-based graph, I think, instead.
Yeah, I think he kind of consolidated the titles a bit to make them a bit more mesh. But even then, data engineer still stood out. And
Well, and I think this is supposed to be 35%, right? So 0.35 fraction, 35%. So
yeah,
that's
let's hope so.
a big chunk of jobs, right? We're talking about there.
Yeah, I think if you're to add all those, they add to one. It looks
Yeah.
like the takeaways is interesting though. If you want to scroll down, I thought this was sort of the we talk about this a lot, where machine learning, it's been focused so much on building models for the last 5 to 8 years, I suppose, or 9 years if you want to go back to so. And I guess with that said, the world's definitely changed since then. And the author astutely points this out. You got frameworks like PyTorch, TensorFlow, which make machine learning insanely easy, and deep learning as well. And then sklearn makes kind of classical methods really easy. And so the amount of time you need to spend building models, I would say, is just it's dropped a lot. And I don't know if that's like the most important thing for a data scientist to focus on right now. So
Yeah. And yet the problem is that so many of your online schools and competitions focus on model building, right? Kaggle, it's all about model building, essentially. Like solve this data problem, which passengers from the Titanic are the most likely to survive. So yeah, there definitely seems to be a split between what's popular and what's actually needed by startups and more mature companies day to day.
Do you want to scroll down a bit more? There was a quote here that I really liked. Where was that?
Keep going.
Yeah. So no. So it says. Oh, sorry. Stop. So yeah. This the second sentence there. So does that mean you shouldn't study data science? No. But yeah, I'll just read. What it means is that the competition is going to be tougher. There are going to be fewer positions available for what is looking to be an abundance of newcomers to the market, trained to do data scientists. Totally agree with this. We see this in quite a few of the data science office hour chats that we're involved in, as well as other groups. I think there's a lot of people that want to get into data science, but it is a very crowded field at this point. There's a lot of new people, and
there's a glut, right? There's a glut of people who have a basic skill set, but not necessarily a lot of industry experience. Unfortunately, that puts you in a tough position. I think there's unfortunately still a lack of training for data engineering, which is something we talked about a lot, but there's just an unfilled demand there as far as we can tell.
Yeah, so I think we have some thoughts on the future. Just want to stop sharing real quick. We can kind of switch back to our the Matt and Joe show. So I think we had some notes on this, but maybe some thoughts on where data engineering is going in 2021.
I think we're going to continue to see this migration toward cloud data warehouses. And the great thing about cloud data warehouses is that In many cases, they're more scalable even than Hadoop, especially for a small organization that can't afford to buy 1,000 nodes. You have an extremely scalable system just out of
Mm-hmm.
the box, and you can also serve traditional data warehousing needs. Now, data engineers actually need to get better at handling cloud data warehouses and integrating them with other systems. And so, in many cases, that means better SQL skills. And it also just means a better understanding of interop and better orchestration skills, frankly.
Mm-hmm. I think the trend also is that the tools are just getting better and they're getting simpler, right?
Yep.
So like data warehousing is like super simple. Pipelines are super simple depending on how you go about it. I mean, if you're going to go with like Fivetran, for example, that's basically just set up connectors and you're done, right?
Yeah.
So, um, I think it's just going to be continue to be more of a trend. There's a lot of companies that are in the data pipeline space. No shortage of different flavors of pipelines and simplicity, and it's only going to get simpler. Certainly with enterprise grade tools, there's always going to be some complexity because it's enterprise grade. But for the vast majority of companies where you're just hooking up, a MySQL database to your data warehouse, that's a very much solved problem. And we would suggest, if at all possible, just find off-the-shelf tools to do that because it's been solved. You
Yeah.
don't
I
need
mean,
to rewrite the millionth connector for MySQL to Snowflake, for example. That's something that's already been done.
yeah, I mean, in some sense, one of the unsolved problems is just properly evaluating labor costs versus the cost of buying a tool off the shelf, right? There's just this misallocation of spend sometimes, and you end up spending a huge amount of money on engineers just kind of babysitting fairly basic tasks.
Yeah, big time.
Yeah.
And let me see. I think the other aspect of this is, machine learning, right?
Mhm.
So, productionizing machine learning is getting a lot easier. And the variety of aspects where you're talking data cleaning, feature engineering, model hosting. I mean, seems like they're in any niche that we just described and many others, model debugging, monitoring. It's like
Mhm.
there's at least a dozen startups in each of these tiny
Exactly.
niches, all competing. They're all really bright people and funded by VCs, and who knows how that's going to shake out. But there's a lot of tooling, and that space is going to get a lot simpler too. So,
Yep. Yep.
but
Use tools basically rather than trying to reinvent the wheel every time.
yeah, I think the days of like bespoke data engineering, that's I think it's coming to an end. So
Yeah, I mean, unless you're Facebook or Google or some huge company that wants to invent their own frameworks because you have a very specific use case and you have the resources. I mean, what did we read the other day that Google supposedly has like 1,000 engineers just working on TensorFlow, which is
just crazy, right?
it's an insane number of engineers. It's like, well, okay, you as a small startup, do you really want to be trying to compete with that? Like, just use stuff that's already out there, basically.
hmm Yeah, and so I mean, there's still probably going to be new algorithms coming out and new
If that's your
approaches,
secret
and
sauce,
what's that?
if that's your secret sauce, then work on it, obviously. Yeah.
For sure. I think another direction data engineering is going in 2021 and probably beyond is I think data engineering itself is just going to be changing.
Yeah.
You have the analytics engineer. That's a new title. It's more analytics focused. Sort of an analyst, quasi, as an engineer. You have a machine learning engineer, and actually I think software engineers. That's the artificial distinction between software engineering and data engineering is going to start disappearing. It's just because apps and the data they generate and are used downstream, they aren't mutually exclusive.
Right.
So,
Yeah. And if nothing else, we both talk about the need for like cradle to grave data engineering, which means that doesn't mean the data engineer necessarily designs the data structures in an application, but there's at least communication, right? I mean, in the past, well, still in the present, to be frank, we've seen the situation where the software developers design the data structures and then they get thrown over the wall. And somehow the data engineers are supposed to clean everything up. And so in a healthy organization, you want communication going back and saying, look, you're not collecting the right metrics for our app to have good analytics. And then hopefully you get this cycle of improved data collection, data structure that then flows into analytics downstream.
mhm,
Yeah.
yeah.
Yeah, because you should definitely that hard divide is very unhealthy in terms of developing good analytics.
hmm Yeah, for sure. I think finally there's a few core problems that I think data engineers are going to continue addressing and doing a better job at addressing either through better methodologies or better technologies. So areas like orchestration. I don't know if you want to talk about orchestration, Matt.
Yeah. Orchestration, especially in a cloud environment, if you look at your more traditional ETL tools for the enterprise, things like DNX, those tools were all about like sucking data out, actually transforming it and pushing it somewhere. In the cloud environment, you don't necessarily need that, right? We talk a lot about ELT, where you just use the database itself to do all the transformation and cleaning. But to do that, you have to somehow manage all these processes. And you have this concept of the DAG, right? Directed acyclic graph. You have a whole bunch of tasks with a whole bunch of dependencies, and you need to keep track of them all and say, okay, once this piece is done, then I can do this piece down here. And then this piece just depends on these three other upstreams. Just keeping track of all of that, alerting when it fails, retrying, orchestration, right? That's what Airflow and Prefect fundamentally are designed to do. And they're designed to communicate with a lot of different cloud services and cloud data systems on your behalf.
Mm-hmm. So I guess, for that, it's really a question: do you want to build or buy?
Exactly. Yeah.
Right. And so, because you could build your own Airflow cluster, you could, stand it up, and then you could go with Astronomer, Cloud Composer, AWS Airflow,
Or Matillion, if you
whatever, or
want really,
Matillion, right? Or
yeah,
Fivetran, you
low
could do
code.
that
Yeah.
too. And,
Yep.
um, so I guess, so that'll be interesting to see how it consolidates. On one hand, I see people, going the more code route, and the other hand are just, punching the credit card in and hooking up Fivetran.
Yeah. And,
Get it
and
done.
really, the parameter here should not be your level of talent, right? It's not a question of whether you can write Airflow code. It's a question of whether you need to, because it is a big management burden. If you write your own code-based data pipelines in Airflow, it gives you way more flexibility, but it comes at a cost of complexity. If you can do everything you need to in a graphical tool like Matillion, then maybe you should and use your time somewhere else.
Yep. I think streaming's another one.
Yep.
So, the world's definitely moving more towards real time, whatever that means. So,
Well, I think my opinion too, is that batch itself has become more and more a solved problem, right? Like we're going to see a lot less engineering time spent on Hadoop this coming year. And what are you going to spend your time on? Well, probably more real-time systems. I mean, that's where the emphasis on engineering is going to be, because batch is such a solved problem now.
is it a solved problem though, do you think?
Okay, so it depends on what we're talking about, right? But if you need to do basic data transformations, then you can use something off the shelf, I think, for that, like a Presto or a BigQuery or a Snowflake. Yeah. Yeah. Fundamentally, it
Yeah.
depends on what types of data transformation you want to do. What about from your perspective? Like, what are the hard parts of batch right now?
I think it comes down to actually issues that are unrelated to batch,
Interesting.
or streaming. And that's just, like knowing your data. That's
Yep.
still,
No, that is a good point.
a big issue. Data quality is a really big issue. Data
Yeah.
governance, modeling your data.
Yeah.
That's another big issue, right? And so I think the role of a data engineer is actually going to move more towards, um, engineering systems that help in those areas too, right?
Mm.
Governance, quality, modeling, all the things that'll trip up anybody downstream, whether you're talking real time or batch. Now, to answer your question again about what are some of the challenges of batch
Mhm.
specifically, um, yeah, I think it really just does stem from just not having an idea of how that data is going to be used downstream.
Yeah.
Because like the process by which you would do batch, data movements, it's pretty simple, right? Um, and so, when it's not simple, it usually comes down to like data quality issues. Like you don't have timestamps in your data, for example, and you don't know
Mhm.
how to like, partition it correctly to move. But as you move into more streaming systems, we'll see what happens if, maybe there's ways to circumvent these issues. But streaming may also just help you do like dumb things faster. So,
That's the problem, right? Like you want to decide when it's appropriate to use streaming. And that's where I would say I think streaming really, it's not just a buzzword, right? It's a real thing that companies are going to move to more streaming. At the same time, figure out what you're actually going to do with it when you get there, right? What's the
mhm.
real business proposition for you? Or like you said, are you just going to do dumb things faster? I've heard it
Yeah.
called chasing your tail, right? Like more signal just means more wasted time running in
Mhm.
circles if you're not careful.
Yeah, but we're seeing a lot of activity in the streaming area though right now. So,
Definitely.
and I think it's only going to continue just because the pace of, analytics is moving towards, even a 15-minute gap between data is, for some of our clients, is unacceptable, right? And I
Right.
could see that, shortening for, and whatever value they derive from that is, up to them. But, the fact is just that the expectations are towards, shorter time windows for everything. And, concurrently, we're also seeing a large interest in change data capture tools right now for that very
Right.
reason, because people want to get insights from the transactional databases faster. So, but that's that, if you step outside of the database discussion and look at more event-driven systems in general, that's also, becoming more popular, where, things may, data may just bypass the database in general and just go straight to an event messaging queue or something, right? So,
Yeah. I think Kafka really pioneered that, and
mhm.
we've seen a lot of companies adopt approaches similar to that, especially in very analytics heavy applications. It's like, why not just flow the data right into a stream and then try to handle it analytically instead of thinking in terms of current database state, right? Traditional database like a Postgres is all about what's my state right now. And then you can use CDC to event that out. But there's another paradigm that says, why don't we just think of it all as events instead? And then you can do things like query within a window or query at a particular point in time.
Yep. Yeah,
Yeah.
exactly. So, well, cool. I think that covers it for today. We
Oh, we
can
could talk all
talk on
day,
and
but
on.
it's a vast topic, right?
Yeah, it's a
But
big topic, and
let's
well, yeah,
stop
but
before
I
we.
think it's good to start the year off with a couple of good articles that were getting a lot of attention on data engineering. And again, the what we're seeing out there is, data engineering it's becoming a more popular topic all of a sudden. I'm not sure
Yeah.
what's going on, but it is what it is.
I think part of it is just supply and demand. I think what would you say in terms of the definition of the modern data engineer? The term's been around for a long time, but in terms of it, the modern usage, the usage we use is probably like 5 years. It's been around for that amount of time. And I think just as this article talked about the need to hire data engineers, there are just lots of open postings and lots of need. Once companies are finally succeeding in data science, they realize their bottleneck is the data engineers, and they just can't find enough of them. So
Well, the data science is usually successful because they've had good data engineering too. If you didn't have good data engineering, but you had good data science, I'd be curious
very,
how you did that.
yeah, or maybe that just means your data sets are tiny and you can do everything
Yeah,
yourself, frankly.
true.
And that's the case for many small organizations. There's nothing wrong with that. But
Mm-mm.
once the data starts to get large and complex and there's timeliness, then you get into serious data engineering.
Yeah, for sure. Well, cool. I think it's a good place to end it. But
Yeah,
anyway, have a good week. We'll see you next week. So,
take care.
all right, bye bye.